We're going to work on some problems here. We're finding the equation of the ellipse given some descriptions, okay? So an ellipse with endpoints on its major axes of 0 to -6, 0, -6, 0, 6. So that means its major axis is 12 units long. The A value is 6, okay? The minor axis is 8 units long. So that should mean that it spans from along the y-axis from -4 to +4. So we want to find its equation, we want to find the appropriate equation, the coordinates of the foci, and the eccentricity, okay? So, given the coordinates of the vertices, which are the endpoints of the major axes, we know that the major axis is oriented along the y-axis, since the points are given coincident on the y-axis, okay? And therefore the minor axis is going to coincide along the x-axis, running from -4 to +4, okay? So therefore the equation is as stated here, the difference being that the orientation is determined by the A value, which in this case is underneath the A value is always the larger value, which is in this case underneath the Y variable, okay? The equation or the focus using the focused equation is, okay, A squared minus B squared, which of course is going to be 36 minus 16, radical 20, that's 2 radical 5, and that is of course along the y-axis, because the major axis is y, and the last thing we want is the eccentricity, which of course is c over a, so that's 2 radical 5 over 6, and if you wanted a decimal value to see how much that deviated from a circle, you could do so, okay? One last thing. What about equations of ellipses which are not centered at the origin, okay? So just like that of a circle, you account for it as we're going to show you here, okay? So let's just pull this all up. So for an ellipse whose center is at some point other than the origin, say hk, the equation is going to be y minus k, the quantity squared over a squared, plus x minus h, the quantity squared over b squared, if it's oriented with the major axes in this direction, in which case we should agree that the major axis is the line x equals h, and of course the foci are going to be at that value of c, which is above and below the y coordinate, okay? So it looks like we can establish that the foci are h comma k plus c and h comma k minus c, okay? And the same thing goes here if the orientation is horizontal, okay? So again, we're just going to, much like that of a circle, we're going to have the h and k values indicated here. The a value is always going to be larger, so we're going to know the orientation. We should always be able to determine, once the orientation, the major axes, whether it's horizontal in this case or vertical in the previous case, and the foci are going to be c units left and right of the center on the major axes, okay? So we're taking another example. Given the ellipse with major axes as indicated here, with major axes endpoints, -5, 2, and 3, 2, and the minor axis 6 units long, find the equation of the ellipse, okay? So from what's given, we should agree that with the coordinates given, we should agree that the major axis, okay, is along the line y equals 2, okay? Is along the line y equals 2. okay, because you can see here, okay, the y values of 2 is, okay, along the y equals 2, okay? The midpoint of those is, of course, going to be the center, which is going to be at negative 1, 2, okay? From there, of course, we can find our h and k values, all right? Given the ellipse with major axes endpoints here, we can see that the major axis spans from negative 5 to 3, so that's a span of 8 units, okay? So the b value, so the a value is going to be 4, okay? And since the minor axis is spanning 6 units, that's the b value is going to be 3. Again, the major axis has the a value, so it's oriented in this sense, okay? So with that, we're able to find the equation of that ellipse which meets those descriptions, okay? So it might help if you sketch it out and you could see things a little bit more clearly, okay? That might help, okay? Let's see. Okay, so this, in terms of completing the square, I think we'll come back to that in yet one last video, okay? So that'll do it for this one.